Hello friends, myself R.D. Mahajan presenting my video on Cauchy's residue theorem. If f of z is equals to p of z divided by q of z has a simple pole at point z is equals to z0 such that p of z0 is not equals to 0, then the residue of that function f of z at the point z is equals to z0 is equals to p of z divided by q dash of z, differentiation of q with respect to z at point z is equals to z0, and therefore substituting the value or taking limit at z tends to z0, we get p of z0 divided by q dash of z0. Therefore this is one important note to find the residue, the one technique to find the residue. Then using this we try to solve one simple problem. Evaluate control integral of cot of z with respect to z over curve C, where that curve C is mod z is equals to 5, standard circle, center at origin, radius 5. But here given function is f of z as cot z. We can rewrite that as cos z by sin z. Then to determine the pole, we equate this term to 0. We get of sin z as sin z is equals to 0. Therefore, z is equals to sin inverse of 0. And values for sin inverse 0 are plus minus n pi, with n is equals to 0, 1, 2 and so on. For n is equals to 0, we get z is equals to 0. For n is equals to 1, we get z is equals to plus minus pi. For n equal to 2, we get z is equal to plus minus 2 pi and so on. Then we check whether the point lies inside or on or outside the curve. Therefore, mod of z at z is equals to 0, it becomes mod of 0, absolute value of 0 is 0. Therefore, that point lies less than 5, 0 less than 5. Therefore, point lies inside. Point lies inside curve C. Next, mod of z at z equals to plus minus pi. Absolute value of plus minus pi is 3.14, again less than 5. Therefore, point lies inside curve C. Next, we check absolute value of z at z is equals to plus minus 2 pi, plus pi and plus 2 pi and minus 2 pi. The absolute value of that is 2 multiplied by 3.14. That value is 6.28. Definitely greater than 5. Therefore, point lies outside. Both the point lies outside. And then the next all other points lies outside, as this point lies outside. Therefore, remaining point lies outside C. Means only 3 points lies inside, that is z is equals to 0, z is equals to pi and z is equals to minus pi. That 3 point lies inside the curve C and all of the remaining point lies outside the curve C. Means we require to find residue at first pole, residue at the second pole and residue at the, then finding the residue of this function f of z nothing but residue of cos z upon sin z at point z is equals to z0. Therefore, at first pole z is equals to 0, we get residue of that function f at z is equals to 0 as a residue of cos z upon sin z at z is equals to 0, and as cos 0 is 1 not equals to 0, this residue at z is equals to 0 is equals to a residue of differentiating denominator term with respect to z, we get cos z upon cos z. Differentiation of sin z is cos z at z is equals to 0. Substituting the value of z as 0 here, we get cos 0 divided by cos 0. Cos 0 is 1, 1 by 1 we get that value as 1. This is the first residue at the point z is equals to 0. Then we determine the second residue. Then residue at point z is equals to pi is nothing but residue of that cos z upon sin z at z is equals to pi. Then we check the value of that cos pi, minus 1, sorry. Cos pi is minus 1, which is not equals to 0, and therefore we get a residue at z is equals to pi, nothing but cos z divided by differentiation of sin z. Derivative of sin z is cos z at z is equals to pi. Substituting z as pi, we get cos pi upon cos pi. Value of cos pi is minus 1. Again, value of cos pi is minus 1. Minus minus get cancelled. We get that value as 1. Or we can cancel this cos pi. We get directly the value as 1. Therefore, the second residue at the point z is equals to pi is residue of that function f of z at z is equals to minus pi. Nothing but a residue of that cos z upon sin z at z is equals to minus pi. Then as the value of cos of minus pi is cos pi and the value of cos pi is minus 1, not equal, residue of the function at z is equals to minus pi is cos z upon differentiation of sin z. Derivative of sin z is cos z, and at the point z is equals to minus pi. Substituting the z as minus pi, we get cos of minus pi is nothing but cos pi, and value of cos pi is minus 1, divided by differentiation of sin z is cos z, and its value at z is equals to minus pi. Cos of minus pi is once again minus 1. Minus minus we get plus 1. Therefore, the third residue is plus 1. And then we apply that Cauchy's. Therefore, applying Cauchy's residue theorem, the value of this contour integral of cot z with respect to z over that curve C is 2 pi I multiplied by sum of the residues. And therefore, we get that value as 2 pi I. First residue is 1, second residue is also 1, and third residue is also 1. And therefore, 3 into 2 pi I, we get that value as 6 pi I as the answer or the value of that contour integral by applying Cauchy's residue theorem. One more I will discuss in my next video. Therefore, if you like my video, please share it as well as subscribe to my channel to receive the notification of my new videos. For that, you have to press the bell icon. Thank you. Thanks for watching.